Welcome back. In the last session, for the problem number 3, we just solved and then we got the answer. But I told that I can explain in a different way, right? And I told that it is 1 by GM basically, okay? Now, let me erase everything. Right? Now, this is fine. Now I can directly explain from here. What is VB? Right? Instead of VB, can I say this is nothing but VDS? Okay? Therefore, what is the resistance? Dynamic resistance R is equal to change in VDS to change in ID, right? Change in VDS to change in ID. What is VDS for diode connected transistor? For diode connected transistor, VDS is nothing but VGS. Therefore, this is nothing but change in VGS to change in ID. Right? Therefore, what is this? This is nothing but 1 by change in ID to change in VGS. When VDS is constant, but here VDS is nothing but VGS. Therefore, here VDS is not constant, right? But remember, if you take ideal equation where ID is equal to mu n C ox W by 2 L into VGS minus VT whole square, 1 plus lambda VDS, then only. But if there is no 1 plus lambda VDS, your ID is only function of VGS, your ID is independent of VDS, then whether you take VDS constant or not, doesn't matter. Therefore, for ideal model, this is nothing but 1 by GM. What I mean is, if you take ideal model, what is ID? ID is equal to mu n C ox W by 2L into VGS minus VT whole square. Then what is GM definition? GM definition is nothing but change in ID or dou ID, anything is fine, with respect to change in VGS. That's it. Because whether you say VDS is constant or not required, because it is independent of VGS. Sorry, VDS. If it is independent of VDS, doesn't matter. Therefore, it is simply delta ID by delta VGS. Okay. But if you take practical, practical means considering channel length modulation. If you consider channel length modulation, ID is nothing but mu n C ox W by 2L into VGS minus VT whole square into 1 plus lambda into VDS. Right? Therefore, in this case, what is GM? In this case, the GM is, because it is function of both VGS and then VDS. Then change in ID, because of change in VGS, we have to keep VDS constant, because if you don't keep VDS constant, your ID is also function of VDS now. Right? Here your ID is not function of VDS, therefore whether you say VDS constant or not constant doesn't matter. Therefore, with respect to practical scenario, we have to give the definition. Therefore, we should not give the definition for ideal scenario, practical scenario. The definition is it is valid for any condition. Therefore, this is the original definition where VDS is constant. This is what I gave, right? Both are same. No need to say VDS constant because it is independent of VDS. That's why delta ID by delta VGS, even the VDS is nothing but VGS which is changing, doesn't matter because it is ideal scenario. If you see the problem, saying neglect body effect, channel length modulation effect means ideal model. Therefore, indirectly asking for ideal model only. Therefore, this is what is the GM which we used. Therefore, what is R? The dynamic resistance or AC resistance of diode connected MOSFET is 1 by GM. That is what it is. Okay, take it. Now this is not VB, I am just directly saying VDS. When I say practical, it has many effects, but one of the effects we included, that is what is channel length modulation. And if you include body effect, the VT also will be a function of the VDS, but it is simply VT which is represented. Then if you continue, there are so many practical effects to be considered, and it will match to the hardware diode current, drain current with respect to the VGS and then VDS. Okay. Done, right? Okay. Now problem number 4. In the circuit shown below, for the MOS transistors, mu n Cox is equal to 100 microampere per volt square, and the threshold voltage is 1 volt, and asking the voltage Vx at the source of upper transistor is. This is GATE 2011 for 2 marks. Okay. Problem number 4. Let me erase. Given mu n Cox is equal to 100 microampere per volt square, and Vt, what is Vt? 1 volt? Yes, 1 volt. 4, 1, 5 volt, 6 volt. Then the circuit is this is what is 6 volt, right? Vx 5. Now asking for Vx. Here what is the W by L? W by L is given. Here also W by L is given for this MOSFET. Therefore 1 and 4. Let me write 2 and then W by L of 1. This is what is, let us say, MOSFET 1 M1, and this is MOSFET 2 M2, right? Asking for Vx. Therefore what is Vx? Okay, this is what is the problem. GATE 2011, option A 1 volt, option B 2 volt, option 3 volt, option D 3.67 volt. Now how will you solve? How will you solve? Or if you already tried to solve, well and good, then after solving the problem in the classroom, you can compare with the procedure what you have followed, then that is fine. If you don't solve or if you didn't solve, then you can see now, but it's better if you come up with your own solution or if your own procedure even though answer is not correct. Okay, then you'll understand at least whatever you have done or whatever you did, the mistakes you will understand. That is fine. Now we need to find Vx, right? Now first of all, let's define the terminals. Can I say this is drain and this is source, because this voltage will be definitely less than drain, therefore always source is lower potential, and this is gate, and this is gate, and this is source, this is drain. This is in saturation, no doubt about it, this is in saturation. Okay. Now what is the state of the circuit, right? What is the state of the circuit? Maybe after getting Vx we will understand, but before that what is the state of the circuit? Okay. Now let us say, maybe for your understanding, we have a capacitor here. Let us say we have a capacitor here. Alright, I am explaining the problem because you may say that you may start with something we don't know, right? Therefore what I say, how to start the problem. Time t is equal to 0. I'm just taking time t is equal to 0. This is important. The same procedure can be applied. Everything, I mean, with this procedure, it will explain everything. Okay. Now, if I take NMOS, let us say initially, let us say this is what is having some capacitor, because I told, right, MOSFET output is nothing but load only. This is your Vx. Let us say Vx is equal to 0 at time t is equal to 0. I'm just taking initial voltage is 0. Okay. But now this is what is having 5 volt. Now this is 6 volt. Okay. Therefore now this is gate, drain, source, drain, source, gate. Therefore now tell me, if you start the output voltage from 0, it will tell this story, but at time t is equal to 0, under steady state whatever you get, that is what is your answer which we need to calculate. You understand the point? I'm starting from 0, then I'm trying to, because I know now something, Vx is equal to 0, but it is not the final voltage. I'm saying time t is equal to 0. Then with this, if you start, something will happen. Ultimately it will drive you to get the steady state answer. That is nothing but I can say time t is equal to infinity. That is what is the answer which we need to find. Got the procedure? Fine. Now if we continue, therefore tell me, your capacitor is initially uncharged. Vx is 0. When Vx is 0, let's see the strength of the MOSFET. Let us say this is M2, state of the MOSFET, not the strength, state of the MOSFET. Therefore tell me what about MOSFET M1. The MOSFET M1, Vx is 0, gate voltage is 0, therefore gate to source is 0, M1 is off, because your gate to source voltage of M1 is equal to 0, therefore this is off. What about M2? What is gate to source voltage? Your gate is 5, what is source? 0, therefore gate to source, VGS is equal to 5 minus 0, 5 volt. And what is VDS? What is VDS? 6 and then 0, 6 volt. Right? Therefore, your VGS is greater than or equal to VT? Yes, this is greater than or equal to VT, where VT is equal to 1 volt. This is true. Therefore, let's see what is the region of the transistor. We want region of the transistor. That is important. Okay. Therefore, now you know what is the region of the transistor. If VDS, always check for saturation region. If VDS is greater than or equal to VGS minus VT, then what is VDS? 6. What is VGS? 5. What is VT? 1. 6 is greater than or equal to 4. Is this true? True. Therefore, what is the region of the transistor? Saturation. What is the region of the transistor? Saturation. Therefore, tell me, can I represent the circuit like this? This is what is Vx. I want space. Okay, nothing wrong, but I want space. This is what is your capacitor. Vx is equal to 0 at a time t is equal to 0. Okay. Now, therefore, what is equivalent circuit? Therefore, the equivalent circuit is your M2 is in saturation. Therefore, can I say it is a current source? And your M1 is off. Your M1 is off. Therefore, that is open circuit. But we have a capacitor here. But this is nothing but your Vx. Therefore, now this is what is 6 volt. Now, I am explaining time t greater than or equal to 0. Therefore, Vx is equal to 0 at a time t is equal to 0. Right? Therefore, now tell me, this is what your PMOS, sorry, NMOS. Therefore, let me call this as I2, because this is M2. Right? There is a current. If there is a current and this is off, when this is off, then this current should flow through what? Should flow through capacitor. There is no way. There is no way. Therefore, when this current is flowing through capacitor, when this current is flowing through the capacitor, then your Vx starts increasing from 0. When Vx starts increasing from 0. Therefore, now tell me, as VGS increases, what will happen? That will increase. Why? Because the current is continuously flowing. There is no way. Then this Vx will be increasing. definitely at a particular point your Vx will cross 1 volt. When Vx is crossing 1 volt, why specially 1 volt? Because threshold voltage of M1 is 1 volt. Because the same Vx is nothing but VGS, right? Once this Vx is crossing 1 volt, your VGS will be crossing 1 volt. When Vx is crossing 1 volt, remember, it starts turned on and it is directly entering into saturation. Why? Because gate to source voltage equal drain to source voltage. This is always diode current transistor. Immediately it will be like a current source. Then what I am saying, at a particular time, right? You know, maybe at a time t is equal to t1, where your Vx will be greater than or equal to 1 volt. At a particular time t1, where, because your capacitor is charging, when capacitor is charging, the voltage is increasing. At a particular time, the Vx will be crossing 1 volt. Then if that is what is the scenario, then tell me, when Vx is greater than or equal to 1 volt, then tell me your M1 will be on. When M1 is on, when M1 is on, your M1 is on. Now your M1 will be turned on and saturation. Therefore your M1 will be in saturation. Right? Therefore, what will be the state of the circuit? Now this is what is our I2 and now this is what is our I1. Now this is your I1. Now this is what is your I2. Now this is what is 6 volt. Okay? Now still there is a capacitor. That is for your understanding. And now this is what is your Vx. Now this is what is greater than or equal to 1 volt. Okay? Therefore now tell me, if you see here, maybe for your understanding I can give you a small example. Tell me what is VGS of this? When Vx is greater than or equal to 1 volt, right? For transistor M2, right? Transistor M2, both are in saturation only. This is also in saturation. Therefore what is VGS? VGS of M2. When this is what is greater than or equal to 1 volt, this is 5, this is 1. Then can I say your VGS is, when this is 1, your VGS will be approximately or greater than or equal to 1 volt, then it will be less than or equal to 4 volt. What about M1? Your M1 is nothing but that is also in saturation. Then what is your VGS? Greater than or equal to 1 volt. Tell me which is what is stronger. M2 VGS is 4 volt. M1 VGS is 1 volt. Not only that, your M2 strength is too much than this. Therefore, it will carry more current not only because of VGS, that is because of W by L also. Therefore, you will get more and more current from I2. Maybe for your understanding, let me tell you, I2, let us say I2 is nothing but some 10 milliampere. Then let us say your I1 is some 1 milliampere. Just I am taking one example. Don't take these values as granted. I want to say that your I2 is greater than I1. Okay? Not only because of VGS, that is because of your W by L also. Now tell me, this is 10 milliampere, right? Earlier what's happening? Earlier maybe at time t is equal to 0, maybe for your understanding, I can say the I2 whatever you have, you can say some 50 milliampere. Then whatever 50 milliampere you are having, the 50 milliampere is flowing through this. But as Vx is increasing, remember there at time t is equal to 0, what is VGS of M2? 5 volt. Now what is VGS of M2? 4 volt. Your VGS is decreasing slowly. As VGS is decreasing at a time t is equal to 0, 50 milliampere, but slowly the 50 milliampere, let us say, becoming 10 milliampere as this voltage is increasing. Because the VGS of M2, as this voltage is increasing, the VGS of M2 is decreasing. Then the current flowing from M2 through M2 and then charging the capacitor is decreasing. Then let us say 10 milliampere. Once it crosses 1, then this is also turned on. What it may be decreased, I agree, 10 milliampere. But out of 10 milliampere, 1 milliampere is gone, remaining 9 milliampere is still flowing through capacitor. Right? Here, therefore, still there is a current which is what is flowing through it. Not only the current which is flowing through 1 milliampere, but still I can say some 9 milliampere of current is flowing through it. Means still it is charging. It is further charging. As it is charging, let us say it is continued. When this is increasing, as Vx is increasing, the VGS of your M1 will increase, the VGS of your M1 will increase, then the VGS of your M2 will decrease. As this voltage is increasing, the VGS of M2 will decrease and the VGS of M1 will increase. Slowly the strength of your M1 will increase, slowly the strength of your M2 will decrease. At a particular point or at a particular voltage, this current will be equal to this current. Means indirectly the total strength of M2 will be equal to the total strength of your M1 in terms of combination VGS W by L and VGS1 W by L. For what combination or for what Vx, both the transistors will have the same current. That is what is your steady state Vx. That is what is your final voltage. You understand the point? Therefore, I can continue. Therefore, if you continue, therefore tell me, if you continue, what will happen? It will go on, and then this voltage will increase as this voltage is increasing. But the maximum voltage what it can have is nothing but what? The maximum voltage is nothing but what? 4 volt only. Definitely it will not cross 4 volt. Let us say it is less than 4 volt. When it is less than 4 volt, then it is VGS will be less than 1. Then your VDS is nothing but less than 4 means it is more than 2. Therefore, it is always in saturation region. This is also always in saturation region. Therefore, both are in saturation region. Now, we need to calculate. Therefore, now under steady state, I am saying at a time t is equal to infinity. I hope everybody understood. Understood or not? I think up to this point everybody understood. Just greater than or equal to 1 volt. I calculated M2 VGS 4 volt, M1 VGS 1 volt. M2 is stronger than M1. Still it is carrying a current of 10 milliampere. I1 just entered into saturation and carrying a current of 1 milliampere because of less strength. Then still there is effective current which is what is flowing through the capacitor. That is nothing but 9 milliampere. Still your capacitor is charging, therefore your Vx is increasing. As Vx is increasing at a particular point, because as Vx is increasing, the VGS of your M2 will decrease, the VGS of M1 will increase, the strength of your M1 will increase, the strength of your M2 will decrease. At a particular voltage, both the strengths or both the currents will be equal. That is what is under steady state. Therefore, you know, that's what I am saying, as Vx increases, the current I2 decreases and current I1 increases. Therefore, 10 milliampere will decrease, 1 milliampere will increase. At a particular point, both will be equal. Therefore, under steady state, your I1 will be equal to I2. Your I1 will be equal to I2. That is what we need to calculate. Therefore, what is that? Now let us say this is what is our current. Now this is what is our current. Now tell me there is a capacitor. Now this is what your Vx. This is what we need to find, and this is 6 volt, right? And let us say this is your I2 and this is what your I1. Now under steady state both will be equal. When I1 is equal to I2, then tell me when I1 is equal to I2, right? There is a current which is what is flowing through from here to here, but what is the current which is what is flowing through here? Therefore 0 ampere. There is no current entering into capacitor. If there is no current entering into capacitor, your Vx or the voltage across the capacitor is constant. But there is a current which is what is flowing through both the MOSFETs 0 to 6 volts to 0 volt, but I1 is equal to I2. Now we need to calculate for what Vx you will get the equilibrium state or steady state. I explained the problem. But remember, if you go in this way, but maybe this is not subjective type, therefore no need to write very neat and clean, something like this, step by step. In the examination you can do it very fast. Okay, but I'm explaining, if you don't write, we need to understand, right? In the examination, once you understand, you can write it very fast. Okay, now take it, now just tell me, you can solve it. How will you get, what is I1? This is in saturation, use saturation current equation of this. I2, use saturation current equation of this. Equate both of them, you'll get Vx. Problem is over. Take it. I think I just explained and then solve the problem. Very interesting problem. I think similarly we have many problems. Once you understand this, the same way you can continue. Whether you have PMOS, NMOS, whatever it may be, simply if you know the region, we can do it. See here, capacitor is helping us to know what is happening to Vx. It is a parasitic capacitor, but it is helping us always. Remember, wherever there is a violation of KCL, put a capacitor, it will tell you the solution. Wherever there is a violation of KCL, put a capacitor. For example, if there is no capacitor, I am just telling you, if there is no capacitor here, then tell me, this is the current source having some current, this is nothing but off state, there is no current. According to KCL, the incoming current is equal to outgoing current. There is no outgoing current, right? If this is off, then violation of KCL. Wherever there is a violation of KCL, put a capacitor. Your capacitor will be charging, voltage will be increasing, then the state will be going to steady state, then that will give you the steady state answer. Okay? As Vx increases, maybe in bracket I can write down, the VGS2 decreases and VGS1 increases. That is the reason why I2 is decreasing and I1 is increasing. That's why but definitely less than 4, no doubt about it. Remember, these are all bias circuits. People use all these circuits in bias circuits. Some current mirror, GM bias circuit, Widler mirror, Wilson current mirror. There are many biasing circuits people use. Whatever biasing you want or whatever compensation voltages and all you want, we can get it. But further we should have this mathematical analysis or quantitative analysis, right? This is the analysis. If there is a circuit, part of some bias circuit is that, then how to find Vx under steady state. Those things. If you want to change that Vx to a different voltage, what should be adjusted? Those things we should know. Therefore, that is the reason why these problems are asked. These are all subparts of any bias circuits. Okay. Those bias circuits are important for amplifiers. I hope you understood the problem. Remember, I am not explaining the solution. I just explained the problem. This is what is called problem characterization. Now, once you understand the problem and we understood the state and what to be calculated, then simply calculate I1 from M1 and then write M2, I2 from M2, equate both of them, then you will get Vx. Okay, that is the answer. And both are in saturation. Definitely both are in saturation. Because no need to think about M1. Once the VGS is greater than or equal to VT, right? Then M1 is always in saturation. What about M2? Because the VGS, whatever you are saying, right? 1 volt, 2 volt or what? For the 5 minus 2, if you see here 3, but here also VGS, if you calculate it is also always in saturation. No need to think. Maybe if you take one example, then you can see. So let's say 1, that's what we have seen, right? It is 1, 6 minus 1, 5, but VGS is 4. VGS minus VT 3, 6 is always greater than 3, saturation. Therefore both are in saturation. I'll give 30 more seconds, then we will see. Try to solve. Try to equate both the equations and then try to get Vx. Then let's see. Now, therefore, what is I1 for MOSFET 1? I1 is equal to Kn by 2, okay, which is VGS1 minus VT whole square. Therefore, what is Kn by 2? Kn is nothing but mu n Cox W by L. Mu n Cox is 100 micro, W by L is 1. Therefore, this is mu n, instead of all those things, I1 is equal to mu n Cox W by L of transistor 1, right? Therefore, what is mu n Cox? 100 micro, and this is 1. Therefore, 100 micro divided by 2 into VGS1. What is VGS1? M1, what is VGS1? Vx only, right? We don't know Vx. That is what we need to find. Vx minus what is Vt? 1 whole square. Therefore, I1 is nothing but I1 is 50 micro into Vx minus 1 whole square. Call this as equation 2, equation 1. Now, what is I2? I2 is equal to, here, mu n Cox by 2 into W by L of 2 into VGS2 minus VT whole square. What is mu n Cox? 100. Therefore, 50 micro into what is W by L2? 4. Therefore, now this is 4 into what is VGS2? 5 minus Vx. Therefore, 5 minus Vx minus 1 whole square. Therefore, this is nothing but 200 micro into 4 minus Vx whole square. This is I2. We know that I1 is equal to I2. Both are same under steady state. Then for that only we need to find what is Vx. Therefore, under steady state, I1 is equal to I2. Therefore, 50 micro into Vx minus 1 whole square is equal to 200 micro into 4 minus Vx whole square. Right? Then Vx minus 1 divided by 4 minus Vx whole square is equal to, I am checking this, 200 micro by 50 micro. How much is that? Micro will be cancelled. 4. Then Vx minus 1 divided by 4 minus Vx is equal to 2. Then Vx minus 1 is equal to 8 minus 2 Vx. Then 3 Vx is equal to 9. Then Vx is equal to 3 volt. Therefore, what is Vx now? Therefore, when Vx is equal to 3 volt, whatever current you get from here, the same current is flowing. Therefore, you will see short circuit current. Then we don't need actually the capacitor, but we use the capacitor to get the answer. Got it? Everybody understood the procedure? Fine. Therefore, now the answer is Vx is equal to 3 volt. Now let's see, this is in saturation. Let's see, 5 minus 3, 2. 6 minus 3, 3. VDS is greater than VGS minus VT, 1. Therefore, 3 is greater than 1. That is true. Therefore, both are in saturation. Satisfied. That is done. I guess it's over. Now, write down problem number 5. Problem number 5. For the N-channel MOS transistor shown in figure, the threshold voltage is 0.8. Neglect channel length modulation effects. Therefore, ideal model. When the drain voltage VD is equal to 1.6 volt, the drain current ID was found to be 0.5 milliampere. If VD is adjusted to be 2 volt by changing the value of R and VDD, then the new value of ID is. This is also interesting problem. This is GATE 2014, set 2 for 2 marks. Okay. Now, problem number 5. VT is given, that is 0.8, and saying that ID is equal to 0.5 milliampere at VD is equal to 1.6 volt. Now asking if VD is adjusted to 2 volt, for asking for ID at VD is equal to 2 volt. Okay, that is what is asking. Therefore, circuit is almost we are getting diode connected problems only, right? This is drain, source, gate, or VDD. Then asking for ID, right? That's fine. We have 5 minutes for the session. Let's try to see, then if it is not over, we will continue in the next session. Okay. Now, I think the decoding already, the problem is decoded into the statements what I wrote here. Vt is given, which is 0.8. Saying that ID is 0.5 milliampere. ID is 0.5 milliampere when Vd is equal to 1.6. Tell me what is Vd? VGS only. Means when VGS is equal to 1.6 volt, the ID is nothing but 0.5 milliampere. Remember, always the transistor is in saturation. Okay. Now, asking what is ID when Vd is equal to 2 volt. Straightforward, you know, is asking indirectly, right? Therefore, Vd is changed because of VDDR, whatever it may be. But if Vd is becoming 2 volt, therefore what is Vd? This is Vd, right? What is Vd? VGS only, right? Therefore, tell me, when transistor is in saturation, therefore when transistor is in saturation, what is your ID? ID is equal to, we know that, right? ID is equal to Kn by 2 into VGS minus VT whole square, right? Therefore, what is VGS? VGS is nothing but Vd. Therefore, Kn by 2 into Vd minus VT whole square. This is what is your ID. Therefore, he has given already ID is equal to 0.5 milliampere. ID is equal to 0.5 milliampere. Kn by 2, that is not known to you. Or 1 minute. Instead of that, we can do it in a different way. Okay. This is what is your Vd, right? Let me call. Therefore, let me call this as ID1, Vd1. Then what is ID2? For different value of Vd2, can I say Kn by 2 into Vd2 minus Vt whole square? Simple. If Vd is changed from 1.6 to 2, if Vd is changed from 1.6 to 2, then your ID also will change, because Vd is nothing but VGS. When VGS is changing from 1.6 to 2, your ID also will change, right? Then take the ratio, because you know ID, this is nothing but ID1. Call this as ID1 and the ID Vd2. Then let me call this as this. Then try to solve. Take the ratio. Therefore, when you take the ratio, you can take ID2 divided by ID1. If you take ID2 divided by ID1, Kn by 2 will be cancelled. Then it is simply Vdt minus Vt minus Vd1 minus Vt whole square. I think you know everything. You can solve. You'll get it, right? Vd2 is known to you. Vd1 is known to you. Vt is known to you. ID1 is known to you. You'll get ID2. Solve. You'll get it. You have 2 minutes time for this session. Then you can solve. If you don't solve, let's see this in the next session. I think within 2 minutes you try to get the procedure. If you understand the procedure, you don't need this, right? You do it on your own. Thank you.